Everyone, I hope y'all are having a great day. As you see in front of you, with my daughter's help, I created a Bitmoji classroom, just something kind of fun, different to look at for this last week of school. If you go, each one of these things are linked, so you can click here for that math vocabulary website that I use in class, Prodigy, Legends of Learning. I created some new assignments for both of these this week. Also, I found some websites right here under Splash Learn to help you with the multiplying whole numbers times fractions. So remember, you'll need your Google Flash in order to make that work. So this week, you'll watch your Screencastify, which I'm making right now for you. You'll complete the Google form, then play Legends Learning. It's called Newton Pool. I thought you might like it. Complete the quizzes on operations with fractions and whole numbers, and then, of course, your dream box for 20 minutes. Then anytime you need to email me, I've got my website right down here. This Bitmoji classroom is going to be at the top of my Google Classroom for the rest of this year and all summer. So if you need anything, just feel free to holler. Also, over here at our meme poster, if you click on that, there's a meme generator embedded in there, and maybe you can make some funny memes. Make sure they stay appropriate. And if you make any funny ones you want to share, just send them to my email when you get them done. Awesome. Let's get into this week. So we are wrapping up the school year with standard 4.NF.B.4, which is multiplying fractions times whole numbers. So let's click and see. So our first problem, we see there are 8 water bottles, and each bottle is 3/4 filled with water. If we pour all the water together, how many water bottles can be filled up? Again, there are 8 water bottles, and each bottle is 3/4 filled with water. If we pour all the water together, how many water bottles can be filled up? So let's try to figure out how we're going to solve that. So 8 water bottles, and each bottle is 3/4 filled up. How many total water bottles are we going to do? So you've got 8 water bottles times 3/4 filled up, 8 groups of 3/4. So anytime we talked about this in class, anytime we multiply a whole number times a fraction, we got to remember that a whole number can also be represented as a fraction. And that's right, over 1. So if we just multiply through 8 times 3, we're going to get 24. And if we do 1 times 4, we're going to get 4. So we have 24 fourths. Now, can that be used as an answer? Absolutely, 24 fourths. But it said how many full water bottles would be filled up. So then we're going to need to kind of simplify this, reduce this to figure out how many water bottles that is. Well, we've talked several times that fractions are just division. So if we take 24, our numerator, and divide it by 4, our denominator, we'll be able to figure out, that's right, 4 will go in 24 6 times. So how many full water bottles are they going to fill up? They're going to fill up 6. So then let's look at our next problem. So at a birthday party, there are 15 children. Each child will eat 3/16 of a pizza. How many pizzas should the host order? Okay, so we got to think about this. So they're feeding a bunch of kids pizza. They are cutting, or what's our denominator? 16th. So they've cut the pizza into 16 slices. So there are 15 kids. And what they're saying is for every kid is going to eat 3 out of 16 slices. So we've got to figure out how many total pizzas they need to order. Now, this is pretty relevant to me, especially as much basketball as we do and pizza parties and things. I need to know this. So I've got 15 kids times 3/16 of a pizza. So 15 times 3/16 of a pizza. So thinking about that, again, representing a whole number like a fraction, 15 times 3, 15 groups of 3. I could add 15 3 times. I could do standard algorithm. 3 times 5 is 15. Carrying that 1, 3 times 1 is 3 plus 1 more, 4, 45. Okay. For those of you who prefer the area model, 3 into 15. 3 times 10 is 30, and 3 times 5 is 15, and 30 plus 15 is 45. Awesome. So that's 45. And then we have 1 times 16, of course, is 16. Now, those pizzas are cut into 16ths. So that is our denominator. That's our unit fraction. So we've got to figure out how many are hidden here, because you see the top number is bigger than the bottom number. So that means this is what kind of fraction? That's right. It's an improper fraction. So we need to figure out, there's some holes hidden in there somewhere. So we got to figure out 16 will go into 45. Well, I'm sitting here thinking 16 times 3 popped in my head, but I think that's a little bit too much. So what about 16 times 2? And so we could do 16 plus 16 if that's easier for you. So 6 and 6 is 12. Carry the 1. 1, 2, 3. 32. Awesome. Okay. Now 5 minus 2, 3. 4 minus 3, 1. 13. Now will 16 go into 13? No, it will not. So we need at least 2 whole pizzas. And then what do you think this 13 represents? That's right. It's the number of slices we still need. So if we still need 13 slices, you're right. We need to order another pizza. So we need to order 3 whole pizzas in order to feed everyone. Awesome. So today, when you go back into your Math Google Classroom, under Tuesday's required assignments, you are going to find a Google form right here that's going to have your problems for you to work. I think there's only 4 today, so it's really not that hard. Be sure and get you a piece of paper and a pencil in order to help you. Okay. And again, don't hesitate to let me know if you need anything. Send me an email, ask to meet. I'll be happy to help you. But remember, I want you to try your best when you get started before you reach out to me, because I know you can do this. We did lots of these in class. I hope y'all have a great day.